And we're live. Welcome back to the Ubuntu Online Summit. This is the Cloud Track, and today we are doing benchmarking workloads and clouds. Introduce yourself, guys.
So I'm Marco Ceppi, Juju Charmer, and been working the last couple of months on how you should be able to benchmark within Juju.
And I'm Tim Van Steenberg, and I've been working with Marco for a while, also working on benchmarking.
And I'm Adam Israel. I've also been working with Marco and Tim on benchmarking over the last few months.
Awesome. Okay, so let's get started. Marco, when we're talking workloads and clouds, what are you talking about? Like, spin me up on what you mean here and why this is useful for me.
Yeah, so as I'm sure a lot of people watching this have known, kind of understand what Juju does at a high level. It essentially allows you to model how services are deployed, how those services scale, and how they relate to other services and connect. So something we got in the last version of Juju 1.23 was the ability to run actions against a unit or a service. And what this ability for actions is, it allows you to encapsulate kind of runtime knowledge. Basically, it's strongly typed SSH, so you can encapsulate in a repeatable way the execution of a task against either a service or a unit. And we found that that actual portion of the Juju model applies really well to benchmarking. So as Juju Core was developing this feature, we were working alongside them to help them kind of shape how actions will look, and then as they were developing that, we were also developing what benchmarking may look like using this kind of actions. So over the last couple of months, we've been designing essentially how benchmarkings work. We've built a very small library that allows you to easily write and create benchmarks for services. And we feel like it's a very strong and compelling use case for Juju, where not only can you deploy your services, you can connect your services, you can then benchmark that deployment, modify the deployment, change configuration, add additional services, and then benchmark again in the same repeatable fashion. So not only do you get benchmarking of workloads, you can also tune those workloads, and you can benchmark how well your workload works on each of the clouds that Juju works against, which is quite a few and growing every day. So that's really where we've taken benchmarks. That's what we'll be speaking about, is how these benchmarks are designed, how you can execute them, and then kind of the future of benchmarkings within Charms going forward.
Okay, so do you have something to show me?
Yeah, I guess we can go and show you what these kind of benchmarks look like, the libraries and such. This will be just a quick intro, I guess, into actions. So everything we're showing you now, with the exception of the special little benchmark library that we've written and that Adam's working on for the last couple of months, most of this is something you can just do as a normal action. It doesn't even have to be a benchmark. It could just be a normal task you want to write. So that's one of the great things about this, is that it's nothing additional or special. It's the same language, the same tools you'll be using with any other task. It just so happens to be special in nature and definition alone, not necessarily in the implementation. So let me find my terminal. I think this is the one I want to show you guys.
So you're going to show me a bunch of clouds and you're going to benchmark them all at once?
So that would be a great demo to have shown if I was prepared a little better.
Okay, all right.
So actually, speaking of which, let me just see what we got going on. I just upgraded to the latest version of Juju, the latest alpha. So let me just bootstrap a cloud, and we can show benchmarking stuff in the next couple of minutes while this is setting up. But I'll walk you through the structure, and then when we get there, we'll do a little bit of magic. So let's get this opened up, a couple bigger there. So we've got quite a few charms in here. The first one I'm going to show is the Cassandra charm. Google published about a month or two ago a white paper on essentially how they tuned Cassandra on their Google Compute Engine. We thought this was great insight and knowledge on how people who care about the performance and the tuning of an application on any specific cloud will do this stuff. And so what we did is we took a lot of that knowledge, and mainly the knowledge on how they actually tested Cassandra. In this case, they used a tool called Cassandra Stress. Excuse me. And so we took everything that they did for their testing, and we instilled it as an action on the charm. So now you can repeat the same benchmarks that Google was doing in their documents on how they scaled and tuned Cassandra inside the Juju charm, which allows you to replicate their results and validate that actually their assertions are correct when Cassandra is in this configuration with this amount of with these parameters for the benchmarking. These are the results you should get. So we actually have. Stuart Bishop is still working on the next iteration of the Cassandra charm, which makes it far more robust and reliable. Not to say that the current charm is bad by any means, but he's making an even better version of the charm. So when that comes out, we'll be applying that, and we'll be trying to mimic the results that Google's produced and kind of show how the various clouds differ between one run and another. So I'm going to go ahead and do this. There is quite a lot of output in this charm. The charm is very complex. It models a lot of different hooks. But the important things that we're going to be talking about is the actions directory and the actions.yaml file. This is where we'll be defining benchmarks. This is also consequently where you define all actions. So as of 1.23 forward, you'll be able to use actions. The docs are updated. They have all the information you need to know to write actions. So we'll kind of look at this at a high level. And then in the upcoming week or two, we'll be publishing a specific document page on how to actually write and run benchmarks. It's just a little bit of extra stuff to do on top of a standard action. So I'm going to go ahead and open up this actions YAML file just to show you what's going on behind the scenes. So this is very much similar to the format you find for a config.yaml. The only difference is you can model multiple actions in one YAML file. So each top-level key in this YAML file is an action you can execute. In this case, the Cassandra charm only has one action. It's the stress action. And so within that stress action, you have a description of the action, which in this case is just the standard Cassandra benchmark stress tool. And then you can outline a number of parameters. And this follows a JSON spec, so it's actually parameters that are keys and descriptions types, and then they could themselves have nested parameters. So you can actually model quite a lot more complexity inside of an action that you can in the configuration currently in a charm. So it's a very nice deviation from the model, and I think we'll be seeing configuration.yaml grow that ability as well in the near future. So these are almost a one-to-one mapping of the parameters that you would find inside of the Cassandra stress tool. So the number of different keys, the trust store, enabling CQL, CQL3, transport factor, skipping keys, etc. And all of these model somewhat of same defaults of things you just normally want to run. So you don't have to worry about tuning these too much, but if you wanted to mimic certain properties or define certain actions, you can do that by modifying them at the time you execute an action. So the most important one, the one that I've been mostly flipping around with when testing, is the all the way down at the bottom here, the number of keys. So right now it's set to 1,000,000 keys, but you can tune that up or down. That's basically the number of things that it processes in the time it stresses. So when I'm doing it on my laptop, I tend to shrink that number down quite a bit, as my laptop is not nearly as powerful as a distributed cloud environment, but when I'm testing it at larger scale, I may scale that number up. So again, these are all the parameters that you want to modify, and here's some comments on how these were derived that were left in by the author. And so Adam's done a great job of kind of distilling this knowledge down into a service. This is me checking on my Bootstrap. Hey, it's done. So let me just real quickly deploy some stuff for us to benchmark. Huge deploy. So we'll stand up 3 Cassandra nodes, and we'll deploy a PTS charm as well. The Phronix Test Suite charm is quite awesome.
Yeah, I kind of want you to spend some time talking about why we did that and what having the Phronix Test Suite charm, what does that give me?
Yeah. It's going to take, again, a few minutes to stand this up, so I'll transition. We'll finish talking about that, and then we'll talk about the types of charms that we have so far, how to contribute, and where we've kind of gone with this and where we'll be going. So let me also deploy PTS. This is in a slightly different directory. So the Phoronix Test Suite charm, which I'll talk about in a little bit, is actually lives inside the Phoronix Test Suite upstream repository. So if you go ahead and grab the latest version of the Phoronix Test Suite repo on GitHub, in the deploy directory, there's a Juju directory, and just typing juju deploy local trustee/PTS in that directory will get you the latest version of the charm as well as the latest version of PTS. So I've got those standing up and deploying. They'll take a few moments. We'll switch back over here, and I'll just kind of stick this up in the corner so we can watch what's going on there.
And for the sake of convenience, we've submitted the charm as part of PTS. So if you have PTS already on disk somewhere, just do a git pull, and you'll have the charm, so you can start pushing.
Exactly. So. Excuse me. So this is essentially what you model as far as actions go. The important thing is your mind actions are a lot of top-level keys. Inside of them, they have description. Then you can define 0 to n parameters to supply that. So these are things that allow the user to set them as options at the time they execute an action. In this case, it's happen to be benchmarks. So we'll show that in a few moments when these machines come up on the right-hand side. But what I also want to show then is next is the actual action file itself. So actions are, if we look back up at our tree here, there's an actions directory, much like a hooks directory, and in there you'll find a file called stress. This is the mapping. Every top-level key in actions YAML can have a file inside the actions directory, which is named subsequently the same thing. This is very much the model that we have for hooks, where we have install, which is the install event, etc. So let's go ahead and open up the stress one. So this one's written in Bash. We have a helper library. It's part of the charm helpers library. So you'll see callouts of things like CHLP, and then we have a bunch of substitutes. These have analogous counterparts inside of Python. So if you want to write your benchmarking action inside of Python, you could do that as well. Those tools will be available. We'll show some examples of those. So we have we basically, the first thing you want to do inside of a benchmark is call out to benchmark start. This does a bunch of things. It's a convenience wrapper around setting things like when to initiate the counter for when a benchmark is run. So Juju will track when the action starts and stops. But if you have to do a bunch of prerequisites in order to get to the point where you can start the benchmark, this allows you to start an internal timer so we can actually see how long the task actually took to execute instead of rather how long the entire action. So that's if you have to install dependencies or compile things or do a bunch of prerequisites, you can move benchmark start to be all the way at the point which you want to start actually capturing the time that that benchmark one was initiated. From there, we build an argument string that we're going to pass to Cassandra stress. So each one of those options that we outlined as a param inside of the actions YAML can be retrieved using action get. This is a command specific just to an action environment, much like config get is for other hooks. Inside of an action, you can actually also run config get, or you can run the suite of other environment commands, config, get, juju log, relation commands, even if you have the proper prerequisite sets for the relation IDs and such. You can run all of those inside of an action as well. It does run as a standard hook environment. Then we just have this additional commands, which is action get, action set, and action fail, which we'll show a little further down the bottom here. So we're just taking in all the parameters and we're building them and we're correlating them from human readable string, like trust store, to the actual argument you find in the command line. Minus TS, minus C, minus L, etc., so on and so forth. Once we build a huge suite of argument strings, as you can imagine, memorizing each one of these by name would be quite tedious to have to know which flag took what value at what time. But one of the strong points of using Juju to model this is that you don't necessarily have to know all of those. We simply expose in a very human, consumable way the things that you want to set for them. From there, we get a list of the nodes that we have running. So this is anywhere from 1 to n nodes of Cassandra in order to do benchmarking. We create a results directory that has a unique timestamped folder so we can store and parse those results later. We finally execute the Cassandra stress command with the output and the list of arguments and such that we want to pass to it that we built previously. From that point, we then parse the results. So we're essentially taking the output of the stress log and we're piping it through to a Python file that we created called stress2JSON. The Cassandra stress output is, I believe, just a giant text log. So this parser will take care of pulling those environments out. We'll show you what that file looks like in a moment. And then finally we invoke CHLP benchmark finish, which is a stop timer. So things that we could do is if we didn't want to include the parsing time for the benchmark, we could put the CHLP benchmark finish command here. That way we didn't include things like the parsing time within that calculation. And we could even move the benchmark start command to above Cassandra stress if we wanted to get more precise timing tunings. For this case, we wish to include the parsing as part of the time. It's standard across them, so while it might not be the most analogous, it is actually standard in each benchmark run since we're invoking them at the same time of each run. But that's just something that we have there for invoking, starting, and stopping. And then those set internal timers as well as perform several other actions that help to kind of bring this whole benchmarking story to life. So we've got a few machines coming online. It looks like Cassandra 0 and Cassandra 2 are online. Cassandra 1 will probably be available in just a few more moments. So I'm going to show you guys the stress2JSON file just at a very high level so you can see how you can set results. And then from there, we'll start doing some just benchmark runs and talking about other benchmarks that we have. If you have any questions, feel free to dump them in. George, if any questions come up, feel free to interrupt me.
Yep. None so far. Keep them coming, though.
So let me go ahead and close this file down. Yes. So the action/stress2JSON file looks a bit like this. This is just a Python file. It's probably the easiest way that we've had to consume the files and parse the results. Things like action set, these are things that are now in native charm helpers. So you can just simply import from charmhelpers.hookenv action set command. We also have a benchmark class, as you see here, as part of the charm helpers contrib. In the following weeks to come, this will become its own library outside of charm helpers, so you won't need to include the full suite of charm helpers. To use the benchmark tools, just need to install the benchmark tooling shim. We then have a parse stress output results. As you can see, kind of outlines how this looks. It comes out as this, as far as a table header. It looks like a CSV file that's basically generated. So we're having a CSV parser, more or less. The important thing is that we have this idea of we can set action. So this runs the command action -set, and then we can set a set of keys on there. And this can be a multi-nested dictionary of keys. So we use the top level in benchmarking. We prefer people use the top level results key, and then everything down there is considered a top level key. So you have a results.interval key rate. Each result can have up to 3 parameters. The value, which is the raw numerical or string value of that result, a units key, which is the measurement of which that result produced, and this could be, again, value can be something textual or numerical, and the final one that we have that we just recently added, it's not in this example, is the direction, which is, help me out, Adam, is it just fully typed out direction, or is it abbreviated?
It's typed out.
Okay. And this could be either descending or ascending. So this allows authors to define which is better, a higher or a lower value. And of course it can be omitted in things that are textual output. There is no higher or lower value. But for numerical ones like interval key rate, I'm guessing that considering it's the amount of keys a second, the higher the number is, the better. So we're going to say this is descending is the best one. So this allows you as people consuming benchmarks, you'll know these are the values that are produced in this run, the consequent runs, these are the values that are outputted, and I know that the higher value is the better one, or the lower value is the better one, or which way to actually read the output. That way you don't have to be intimately knowledgeable on all the tools that are running and their output formats. You simply know this is my number, this is the unit it was measured in, and this is how I know how to sort it logically, whether it's descending or ascending. Each one of these can take any one of those values. We recommend setting all 3. At a minimum, a value is required. Units are optional, as well as direction. So we simply, once we parse those results, we go through and we build out the results details by just simply saying action set, action set, action set, these values. Finally, the benchmarking class has a composite score method. This allows you to set the set the opinion of this is the one key that, as a user, you should care about. So in this case, it's the interval operation rate. And this is how many operations a second that were run. So you can see it sets this value, the units, and then, of course, the direction, which is descending. So at a very high level, this will come back and it basically says meta.composite. So it's a very easy to spot key in your output results. And this will be the one that you can tell this run was better than this run. All the rest of these results are there to allow you to decide what made this run more powerful than this run, or faster, or better, or stronger. So those are all basically supplementary results designed to help you figure out what's going on. But at a high level, this is really the thing that most people as benchmark authors and consumers will be caring about, is this composite score.
Okay,
and that's it.
Let me interrupt you there because you went on for like 45 minutes. First of all, increase the font size 1. Some people are having a hard time reading. And Colin King asks in IRC, there's a nice demo. Any chance of wrapping up StressNG as its useful stress benchmarking tool? Then a link. And then Michael Larabelle, one of the authors of PTS. I don't know if I think he's a primary author, but I'm sure there are others. He says on the PTS side, that can be tapped from Juju. I was actually looking a few days ago at incorporating StressNG. It does seem straightforward, and I'll have it there soon. I don't know. What do you think about that, Marco?
These are great questions. So StressNG could totally become a charm that's used for benchmarking hardware. In fact, we've made it so that it's very easy, and we'll be publishing templates. Again, I'm sorry we don't have these quite ready for UOS. We're just now polishing this stuff up to last week and even today. So we're still making some minor revisions, but this is basically the image that we'll have going forward. So we will be publishing blog posts, documentation about this, as well as an author, as someone who cares about benchmarking, how it's the quickest way for me to get started so I can start benchmarking things. So we'll have documentation, stubs, and cookbooks to get you to that point where you can just drop in bits of code, modify things you need, and go. So StressNG could totally be a contender. And if it gets rolled into PTS, as Michael is saying, that's even stronger case. You just simply add an action onto the PTS charm saying, this is StressNG, the parameters I want to modify, and then you just basically in the action say, invoke PTS, the PTS/StressNG package or whatever, however it's packaged, and then pass these parameters, and on your way you're going to StressNG. So having that as part of PTS is a great story that we can then say, now you can encompass from a hardware benchmarking perspective, in addition to all the amazing plugins that PTS has, you now have StressNG as an option. Fantastic point, great questions. But yeah, no, you could definitely wrap StressNG. We likely won't be wrapping StressNG. We're looking just to build a set of example benchmarks to get people started with. We're not by no means the expert in all of the benchmarking tools out there. So if you know StressNG, or as Michael was saying, he's like one of the experts at PTS and he can wrap it in PTS, it's much better to have the experts doing that than us, where we know Juju very well, but we don't know all of the benchmarking tools that are out there.
Okay, so has your stuff spun up while we wait for more questions?
Everything is started, so we can start running some benchmarks. My cat's
Do it.
tripped my cables up. Oops. There is one more command I want to mention for actions. We may see this come up. You can actually do an action fail. So if helps if you spell it right. You have more room. Action fail will allow you to say this action has failed. So if you parse the results, something's not valid. Instead of just shelling out and exiting greater than 0, which you would normally do in a hook, that would illuminate an action failure. You can actually do action fail with a message, so you can convey back to the user, hey, you set like these 12 parameters and 4 of them are just wrong. Could you not do that, or could you maybe make them a little better, or maybe here's how you should do them instead. So that allows you to give even additional feedback back to the user, like, hey, thank you for running this, but wasn't quite the right way to do that, or I expected this output, but I got this instead, just to let you know something failed. So it gives you the observability as an author to bring that back up to the user level and say, hey, here's what happened during this, and here's the steps you can take to rectify it. With that, I guess I could probably stop talking. Let's just run some benchmarks.
Yeah, show me something else.
So we have, you can do Juju action is the subcommand you'll be using. There are several other commands within there. So if you have a Juju environment deployed, let's go ahead and just run status real quickly and get rid of this window. Format, regular. really should be, I think, format tubular at this point. So we see we got a bunch of machines spun up. They're on Amazon's U.S. West zone. I couldn't quite get GC working in time for this, but it actually is quite awesome to use. We have 2 services, Cassandra and PTS, so we've got 4 units total, 3 of Cassandra, 1 of PTS. So if I wanted to find out the things that I could do against a unit, you would write Juju action defined, and this may be eventually moving to Juju action list, but for now it's Juju action defined. I want to see everything that I can do for Cassandra, which we know is just stress. So it says stress, the standard Cassandra benchmark stress tool. Perfect. PTS is a little more interesting. It has a couple of canned defaults that, again, not being the experts in benchmarking, we just kind of modeled. We've been working with those in the upstream Pharonics test suite community. They've been giving us great feedback on ways we can help shape this a little better. We have a couple of them. We have a CPU, custom I/O memory, and a smoke test. So these are just a bunch of PTS plugins that we picked out. We found all the CPU-centric ones that we called the CPU. We found all the I/O-centric ones, all the memory tests, and then a smoke test, which is ones that are designed to just quickly benchmark a system, as well as a custom where you can input any PTS plugin you'd like. So I'm going to go ahead and kick off a few actions. So if we're going to do Juju action status, we should get absolutely nothing back because we haven't done anything yet. There are no actions. Thank you, Juju. I'm going to go ahead and say Juju action defined PTS schema. So what this will do is this will show me all of the actions for PTS as well as the parameters that I could apply to it. So I can see that there's a CPU option, CPU-centric tests. It has no properties. You just run it. Custom takes the property of tests. I/O and memory are also there, and smoke has a default for tests, which has several pre-filled values in there, which it runs PHP bench, cache bench, and stream. For the sake of speed, yeah.
Yeah, let's just do those, right?
Yeah, so I'm actually going to do a smaller subset of smoke because stream completes very quickly. Cache bench and PHP bench can take a little bit of time to complete, a couple minutes. So for the sake of brevity, Juju action do PTS smoke tests equal this.
Okay.
This is where I'm going to need a little bit of Juju action help do. I can't quite remember the exact format.
Yeah, it feels like we.
No
feels
flag.
Like we have too many verbs in a row.
So Juju action do on the PTS 0 unit, run the smoke tests, actually custom really, and then the test parameters PTS stream. It's a lot of vocabulary soup in there, but it does somewhat make sense as you type it. It's just a lot to do in there. So I'm going to run this. It'll give me back a UUID. It says it's been queued. Just like with the Juju hook system, actions are queued. So I can actually queue this up several times, and then Juju will properly process them in the whole event queue. So if I run Juju action status, I see that I'll probably have one running, which I have here, the first one I launched, and the other 2 are pending. And as this progresses, we'll see that they move from running to completed, from pending to queued to running, etc. So just like for the same thing, all these actions are asynchronous, which is another great thing as well. I can just queue up a set of actions, walk away, come back, just like with actions you normally would run in a Juju environment. I'm also going to kick off the PTS one. The Cassandra one. I'm just going to use the defaults for that one. Juju action do Cassandra 0 stress.
What cloud are you on? Are you on a local provider?
No, I am on Amazon's AWS West 2 region. Okay. So my laptop isn't going to nuke itself.
Dumb question here. Is there a way to run a... Is it all right if I just ask dumb questions?
You can ask all the dumb questions you want.
Yeah, is there a way to run these benchmarks not just on individual units, but like the service as a whole, right? Let's say I have a Cassandra cluster, and I want to know, like, I don't know, the response time of the...
Sure. That's a great question. In this first release of actions, it's actually only tied to a unit level. So you can queue up. So the thing with, as you notice here, I have 2 actions running simultaneously, one on PTS 0 and one on Cassandra 0. You can queue up multiple benchmark runs to happen on each unit. The Cassandra stress tool will implicitly run against all of the cluster because it is doing the clustering under the scene. So you only need to launch it against one node. But there are cases where you may want to actually launch PTS against all of the units you have in PTS if each one is a unique piece of hardware under the covers.
Right.
So you can do that. You'll just have to invoke it multiple times with each unit, and there's a way you can script that. In the next versions of Juju, 124, 125, 126, we'll see a lot of revisions to the actions framework now that it's out and publicly available. That was one of the first pieces of feedback we got was, I want to run against a service, and I want to run against just the leader of a service, and I want to run against a unit. So those kind of things will be coming out. But that was a great question.
Okay, so in the meantime, put in a for loop. So.
Yeah, so much so. It's so many words, yes. So we should be getting a completed result. Here we go. PTS.
There's one. Yeah.
So the next thing is you grab this giant UUID, and you can do Juju, not Kiki, Juju action fetch the UUID. This will give you the results that occurred during that run. So you see here we have the results key that we set at the very top, and then we have stream add, stream copy, stream scale, and stream triad. These are the 4 metrics that are returned whenever you run the stream plugin for PTS. Each one kind of does a unique set of details that come back. So the PTS charm is just a way that it handles parsing all that for you. So if we run cache bench, we'll get a separate set of data back. But at the very high level, you get a value and a units of measurement. And then finally, we get some additional timing things that come back out from there. Another great thing you can do is if you don't want to type in a 32-character UUID, you can do the first portion of it. Juju's smart enough to figure that out. You can also block. So if you're actually waiting for the results, the Cassandra one's still running, and we're actually I want to see these be done. So if we're going to do Juju action help fetch, you'll notice that there's actually a wait command. So by default, it's set to -1, which means it'll just return immediately with the output. You can set it to 0 or to a set time. 0 will block until it completes, and then otherwise it'll wait for X specified amount of time, 5 seconds, 1 hour. It uses that kind of shorthand. So I'm just going to run fetch wait 0. And we're going to block until this is completed. It should be completing in the next few moments now. But once it's completed, it'll actually dump the output and you can move on. So if you are scripting around actions, which we have a few people who've started doing so, especially with benchmarks, you can run Juju action fetch with wait equals 0 right after you queue up the benchmark. It'll allow you to basically block execution until you get results back or until it fails, one or the other.
Okay.
So I'll give it a few more moments to run. We can start queuing up more benchmarks. We have, as examples of benchmarks, we've written a siege charm, which will allow you to initiate an action on siege, which will siege any one of the web services that you specify that's attached to it. So if you connect siege to MediaWiki and siege to WordPress, as a part of the siege command, you can say, I want you to run siege with these parameters against WordPress or against HA proxy or against MediaWiki, whatever you have connected, and siege will do so. We also have Cassandra, as you've seen. We have PTS initially charmed. We have a lot of great feedback from them that we'll look to incorporate into that charm. We also have a MongoDB benchmark that we've been writing, and we're working on a generic MySQL-like benchmark so that any of the MySQL services that we have floating around there that implement the MySQL interface, MariaDB, MySQL, the charm itself, Percona cluster, those kind of charms, you can all benchmark them at once, essentially, so you can do comparisons of which MySQL service runs the best on my cloud configuration. So those are the kind of core suite of charms that we're launching with. We also have a Rally charm that we'll be creating, Rally being the benchmarking tool for OpenStack. So you can use, just like you can use Juju to stand up OpenStack, you can also use Juju to benchmark your OpenStack deployment and validate that the hardware you've purchased, the underpinnings of your cloud, are as performant as you'd expect. Right,
because it's just another OpenStack service, and we already have those. We just plop it on there.
Exactly. This is taking far longer than I wish to complete, so we'll go on and do a couple comparisons here. So the last thing I forgot to mention, this is actually like the most important thing about benchmarking other than the action itself, is when you're writing a benchmarking action, you should also, well, you have to include also a benchmark interface for the charm. There's a really cool reason for this. We're actually building a benchmark GUI which will allow you to deploy just like the Juju GUI, and you can relate to all the services that have benchmarks to them using this benchmark interface, and we'll be able to aggregate those results from that benchmark run into a nice little web UI. That way, instead of staring at YAML output, you can, just like in the Juju GUI, you can use this benchmark GUI to kind of look at your results and compare them and kind of manage them at that level, which will be a nice thing for those who are doing a lot of benchmarking of hardware or a lot of benchmarking of web services. So this benchmark GUI, something we'll be showing at ODS, and we'll be blogging about after that. It's not quite done yet, but we're getting pretty close to finishing it. So that'll be something else to look forward to. The benchmark interface and relation itself, very straightforward. Let's go back into benchmarking. Cassandra. You simply need to add provides a benchmark interface, and then you'll need to create a benchmark relation joined hook, which looks a little something like this. Just import the benchmark command, invoke the benchmark command with the name of the actions that are benchmarkable. So if we had two actions, stress and stress more, it would look something like this, but you only want to add the actions that are actually benchmark actions. So if you have a backup option or a restore or an additional action that you would normally do that isn't a benchmark, you just won't include it in this invocation of the command. That way, whenever you connect the benchmark GUI, we'll know exactly what results you'll want to see as we collect them as they're outputted. So that's a lot of talking. I'm glad it was recorded. Is there any questions so far? Otherwise, we could do a couple more demos, and we're coming pretty close to the top of the hour in about 20 minutes, so I'm going to make sure if anyone has any questions, we get those out of the way and answered.
So you can basically model your little benchmarks for whatever services and then script up firing it off to individual clouds, right? Like in parallel. Go for a coffee, come back, and then you can say, hey, these instances on this cloud versus these instances on this cloud. Correlate that to price, and then people would dig that.
Yeah, so that's definitely something that you as a user could definitely do if you wanted to find out. If you already have your workload added in Juju, charmed up, then adding benchmarks are really trivial, and there's a huge value add for that as far as if you're testing the waters with different clouds, like Google Compute Engine just came out as a Juju provider. If you want to see how that stacks up against Amazon or your bare metal or DigitalOcean or any other provider, you can do that real easily. It democratizes your ability to choose which cloud works best for your workload. And that ability to tune and choose your cloud, we think, is a very strong thing for people who are actually using Juju in production and who care about the amount of money that they spend in the cloud, which is not trivial for most people.
Okay.
Yeah, but that's definitely something that we'll be looking to harness. I'll give a few more seconds for questions. I'm going to run through Juju Action status again, see what we got going on. It looks like all the PTS ones have completed. They're super quick. I'll launch one more PTS one. We'll just do the straight smoke test, just so you can see what the varying outputs look like. I was really hoping the Cassandra one would finish by now, but it looks like it has taken a while to complete. I probably should have tuned down the number of keys I threw at it for the sake of brevity.
Have you tried this on bare metal, like say in Orange Box or Mark's Garage Mass or something like that, just to get an idea of how bare metal performs against VMs in a cloud?
We really haven't gone that far to test bare metal yet with this. We know it'll work. Juju works on bare metal. We've been really focusing on the developer experience of writing and creating benchmarks. That's really what we feel we can add the most value. Adam and Tim both have some experience in the past of benchmarking services, and I've used Siege a couple times, I'll admit as well, but we're really not subject matter experts when it comes to writing benchmarks. So we just want to make sure that the few examples that we had from people, they worked really well in a Juju environment. Then we'll be looking for people, stewards of the community, in the benchmark community, and the Juju and Charms community, to start creating these benchmarks, and then we will run them everywhere. We'll run them, and we'll be happy to publish results or other people's results as they run benchmarks to help kind of democratize the idea of which workloads work best where.
Mm-hmm. Okay, I'll give it another 20 minutes for questions, or 20 seconds for questions. We got 20 minutes until the next session. So.
Marco, smoke tests with the default params will probably take about 25 minutes.
Perfect. It's PHP bench, isn't it? That will take a while, doesn't it? Well, shot myself in the foot with that demo as well.
Yeah. Well, at least some of it completed. I mean, it's one of those things where it's nice that we give people the tools so you can fire it off before you go to lunch, right? And then come back and do your fetch. Is there an easy way for, other than doing the action fetch, to kind of grab all the aggregated results and dump them somewhere, like either to a file or something like that?
No, not really. None of the current version. Let's go back to this here. Essentially, all you have is define, to do, fetch, and status. Again, it's very easy. The output of each of these commands can be formatted in YAML or JSON. So to build a tool which runs Juju action status, finds all the completed items, and then runs through and fetches each of those as a JSON or YAML to a file is something you can definitely script on top of this. It's very pluggable. All this stuff is available in the WebSocket API, so if you're already interacting with the Juju API, pulling this data out will not be that difficult at all.
Okay, awesome. All right, with that, Colin King would like to remind everyone that when it comes to benchmarking, check out Systems Performance. It's a book by Brendan Gregg, who we just saw at Scale, talking about scalability problems that they're having at Netflix and how they test stuff, and it was very, very interesting things that I could barely understand, but it was pretty awesome. So definitely check that out. Anything else you'd like to say before we wrap up?
Well, I got results back, so I'll just walk through this real quickly.
Sorry, I wasn't looking.
It's okay. So something you'll see slightly different from the PTS charm, and we're making sure we update the PTS to be another good example of this, is the Cassandra charm has this meta value. So meta is the things that benchmark start and stop set for you, which is great because we can figure out when the benchmark was started and stopped. We also get this composite key, which is like the number that defines how well the benchmark had done. So if we had time to run this a few more times, we can see that it took, was that about 12 minutes to run. So if we had 12 more minutes, we could run another one. We can compare the outputs, tweak some parameters. But this is the number one value you care about, is that it took 99,970 operations a second in this time period. The rest of the stuff just kind of builds up to that. We have the ability also to dump raw value. So you can say, here's all the raw keys. As if you've ever run Cassandra stress, these are actually the average of all of these keys over several iterations. These are the raw numbers for each one of those runs, so you can yourself, if you need a more granular view of things, dive down into there. So we'll just pop down to the very bottom here, and then we have the additional stuff that Juju sets for you, which is the timing stuff. But this is why you want to run things like benchmark start and stop, because you get this additional value add on top of that result structure. So that's it. That's it for benchmarking at a high level of benchmarking and stuff. And if you're very interested in this, reach out to us at the Pound Juju channel. I'm Marco Chepi, all one word, as you see in the bottom of the screen when I turn off my screen share. T. Van Steenberg and A. Israel, as well as George Castro. He can help you direct you to us. We'll also be on the Juju mailing list, posting about this stuff in the upcoming weeks. The documentation for it, the examples for it. Getting started resources and such, so you'll have that as well coming forward. So we're very excited about this. We're very excited to show off the work we've been doing. We're very interested in your feedback, especially if you're really into performance, benchmarking, and tuning of workloads.
Cool. And with that, that concludes this session. We'll see everyone at the top of the hour, where we're going to have office hours for Juju, so you can come. If you want to figure out, ask really dumb questions, or you haven't gotten started yet, or you want to get spun up, we'll basically just be sitting around for an hour talking amongst ourselves about Juju, and then you can ask us whatever you want, and we'll help you get started on whatever cloud you have creds for. So with that, thanks, fellas. Looks really exciting. I'm really glad to see us pushing PTS and benchmarking and all that stuff forward. Finally, getting performance and things that are important to people in the cloud out into the forefront. So that's pretty exciting stuff. So with that, we'll see you guys later. Thanks.